So just like we talked in the previous set of videos about using arrays for stacks, here we're going to use arrays to design our queue data structure. So just a reminder of what a queue is. A queue is a data type that stores a collection of elements and allows you to in-queue things, which is to put an element at the back of the queue, at the back of the line, right? Dequeue removes the item from the front of the queue, and sometimes they allow us to have these other methods like checking whether the queue is empty, getting the length of the queue, looking at the first element. Right? So when we design a queue using an array, we're going to have a couple of things. So first is we're going to have an array A, right? An array A that stores all of the values in our queue. Additionally, we're going to have an integer that tells us where the front of the queue is. And we're going to have an additional value called count that we're going to use to tell us how to find the end of the queue when we need to add something. So initially, both the front and the count are set to 0, right? Those are sort of their initialized values because so the count's going to hold how many things are in the queue. And right now there's nothing in the queue. And for fun, we're just going to start the queue at the front of the array. So as we add things to the queue, the front pointer stays the same, and we increment the counter. So here we've added the number 1 to the back of our queue, which is also the front. We have one item in our queue, and it's just this number 1. As we add things, right, 2 goes into the back of the queue, and now we have 2 items, and 3. So we can always find the back of the queue, even though we don't have a pointer here, right? The back of the queue, so the back is just equal to the front plus the count. Here it's, minus 1 to get the last item. But you're going to put something into just the front plus the count, right? The next item, say we wanted to enqueue something else, we would be putting it in front is 0, so it would be 0 plus 3, which is 3, and we'd want to put it right there. And we could keep adding things until we get to the end. Now our queue is full, right? So, but notice that as much as stuff as we've added, we've incremented count, but we've left front right at the beginning. We move front when we remove something from the queue, right? As we dequeue stuff, the front moves to the next item, right? So normally when we think about queues, it's like a line waiting for a cashier or something, and normally we think of the line, the queue moving forward. Here, we're not really moving the queue, we're moving what the front of the queue is, right? So people are standing in their place, and we're figuring out how to go through them. And we can do that for a couple more items. So now we have 7 items in our queue. They start at position 3. What if we wanted to add another thing to our queue now, right? Well, where's the back of the queue? So as long as the queue's not full, right? As long as we don't have 10 items in our queue, we can add another thing, but it's going to go here, right? So we said earlier that it goes into front plus back, so back is equal to front plus count. Here, front is 3. If we do that, then it's 3 plus 7 is 10. 10. And that's out of bounds. So really what we want to do is it's this mod a dot length. So mod 10, and that gives us 0. So that means our next item should go here in element 0 of the array. And again, we want to add something else. So we're going to say back equals front plus count mod a dot length. So that's 3 plus 8 mod 10. So that's 11 mod 10 is equal to 1. And that's this guy, so that's where we're going to add 12. Right? So the size of the queue, we've sort of already discussed this, but the size of the queue is simply the count, right? And now we know that there's 10 items in our queue. And we know the queue is full when count is equal to the length of the array. So the length of the array here, a dot length equals 10. And the count is equal to array dot length. So in this case, it's full. And it's not full anymore, but now it's empty. And it's empty when count equals 0, right? When there's no elements in our queue. And notice that when we end, unlike when we started, count might be 0, but front doesn't necessarily point to the beginning, right? It might point to wherever we left off. You could reset it to the beginning, but you don't necessarily have to. Right? So that's how to use a queue, or how to set up a queue using arrays. In the next set of videos, we'll probably get into lining up with the book, where they use linked lists for queues and arrays. And the one thing that they don't have to do with queues using linked lists is they can never be full, right? A linked list can't be full. But there's a couple caveats that go with that, a little bit more maintenance.